Okay, this question says that there is an electron having mass m, which is to be moved from one point to another point by applying some potential difference V. Okay, clear?
Okay, sir.
Okay, we are not applying any force. Instead of that, we are applying some potential difference V to move the electron from this point to this point, or in order to get some velocity, we are applying some potential difference. So, okay, initially we are applying the potential difference 25 kilovolt. Later, we change the potential difference to 100 kilovolt. So we have to compare the wavelength in both cases. Okay, so lambda, since the electron is moving, it has some wavelength. Lambda equal to h by p, correct? Clear?
Yes, sir.
But p I don't know because velocity of the electron is not given. So I am using another formula. P is momentum is not available. So 2m into kinetic energy. We have another formula. Kinetic energy, I have already explained that. Clear?
Yes, sir.
So kinetic energy, this electron will have a certain kinetic energy. I am trying use this formula, but unfortunately this kinetic energy is not given. Correct? Clear? So, but I can find out the kinetic energy. In which energy the electron will be moving. Understood? Clear? In which energy? This moving electron having some energy, right? That kinetic energy we can find out. You studied in the chapter electrostatics. The kinetic energy or energy of a moving charge. Energy of a moving charge, you have studied that Q into V. V is the potential difference. Have you studied this formula?
Yes, sir. Studied.
A charge Q is moving under a potential difference V. Then then it has energy. It is Q into V. You have studied that. Clear? Clear? You have studied. We have already studied. So in this case the kinetic energy will be Q into V. Here Q is the charge of the electron. Clear? Q is the charge of the electron, which is E. Understood?
Yes, sir.
Let voltage be V. V. I will substitute it later. Okay. So hence lambda is equal to h by root of 2 into m into EV. Clear?
Yes, sir.
So here, okay. So look here. In this case, this h root 2me, all these are constants, right? Clear?
Yes.
All these are constant. 1 minute. Let me change the color. 1 minute. Just 1 minute. Okay, you know that this h root of 2me, all these letters are constant. You agree with me? Clear?
Yes, sir.
So for our convenience, this highlighted letter denoted by some other letter. H by root of 2me will be some constant. Let me denote by some letter. Say A. Okay, let it be A. Okay? Clear?
Okay.
H by root of 2me denoted by A. Root V is there, right? Root V is still inside the square root. Lambda equal to A by root V. A is this highlighted constant, okay, for our convenience. Okay. So now the question is, initially V was 25 kilovolt. Later the voltage changed to 100 kilovolt. What happens to lambda? Clear? Understood? So initially when voltage is V1, wavelength is lambda 1. Understood? Clear?
Yes, sir.
When voltage is V2, there will be a corresponding wavelength. Let it be lambda 2. Okay? You agree with me? If you change the voltage, definitely wavelength will be changed. Understood? You agree with me? Clear?
Yes, sir.
Dividing here, then dividing here. Okay? Correct? Clear? Taking the ratio.
Okay, sir.
So I want the ratio. That's why I am taking the ratio. Lambda 1 by lambda 2 is equal to, A is a constant, it will be cancelled. into root V2 by A. Understood?
Yes, sir.
A will be cancelled. Here in this question, why lambda 1 lambda 2 taken? Because in this question initially V1 equal to 25 kilovolt, correct? Understood? And later V2 voltage is changed to 100 kilovolt. Clear? So correspondingly lambda wavelength will be changed. Clear?
Yes, sir.
So that's why I have taken root V1 and V2. So the lambda 1 and lambda 2 will be the corresponding wavelength. I want the ratio. So lambda 1 by lambda 2 will be equal to what? A cancelled, root of V2 by V1. Correct? Clear?
Yes, sir.
V2 by V1. So root of V2
100 by
100, both of them having same unit, so we need,
unit, so they will
yes,
cancel.
yes, very good. Root 4, correct?
Root 4 ones are
2
times.
2 times. So lambda 1 by lambda 2 equal to 2. So cross multiplying lambda equal to 2 times lambda 2. Clear?
Yes, sir.
Or lambda 2 equal to 1 by 2 times lambda 1. You agree with me?
Yes, sir.
So the question is lambda 2 is equal to how much times lambda 1, right?
Yes, sir.
The voltage is changed, the new wavelength will be how much times the first wavelength. So lambda 2 equal to, okay, the order is not correct. Sorry, 1 minute. The electron used in the electron wave, if the voltage is increased to 100 kilovolt, then de Broglie wavelength associated with the electron will be decrease decrease by 2 times. You understood? Clear?
Okay, sir.
So this problem is clear to you? Okay?
Yes, sir. Understood.
Okay. So can we go to next problem?
Yes, sir. We will.
Okay, 1 minute.